Great. Well, thank you everyone for coming. I'm Bert Wagner, and I have to say, looking around the room, I am really excited to see so many SQL data professionals hear about a talk about storing gigantic strings of text in your databases. I guess before we start, how many people here kind of identify as a DBA or doing DBA type work? More management of the server. Okay. Versus developers. Okay, good. It's pretty good, pretty even mix. That's a little different than what I was expecting, but that's great. I guess another question, how many of us have worked with JSON in the past already? Okay, so also about half the room. That's great. And I guess finally, just let me throw up this slide here. Does anyone think that this is a good idea of just building tables that are all nvarchar max columns? We've got one person raising two hands up, so I'm going to take that as a joke. I am not here to preach about NoSQL databases and anything like that. I love SQL Server. I love relational databases. I do love JSON too, though. In this talk, hopefully by the end of it, you'll know how to appropriately use JSON in SQL Server, both efficiently and with the ease of use of the Microsoft functions in 2016. So just brief background. Once again, I'm Bert Wagner. I'm a business intelligence developer at Progressive Insurance. My day-to-day work is a lot of SSRS, SSIS, MVC.NET, and of course SQL Server, writing queries, mostly building tables, things like that we would expect a business intelligence developer to do. You start talking to me about database backups, and I point to someone else. I have no idea. I know not to run any jobs on Sunday mornings because that's when things get backed up. I also, on the side, I work with a lot of JSON. I have a lot of projects that I do involving JSON, from coffee roasters to bird cams, things like that. I really like JSON, especially being a web app developer, or at least my web app background. I mean, I use this stuff for everything. So when I found out that SQL Server 2016 has these new functions, I was already storing JSON in my databases, but now I can actually do more with them. So that got me really excited, and hopefully by the end of this you'll be excited too. Just for reference, all the demo code and slides are at my website, so don't feel like you have to take super detailed notes. You can always reference them there later on. Here's the agenda for today. It's basically we'll do some high-level stuff, we'll dive down into some demos, and we'll go from there. So since not everybody was familiar with what JSON is, right? So it stands for JavaScript Object Notation, right? So whatever that means. Basically, it's a form of data that you can use in JavaScript, right? And that's kind of its most important use because most of the web runs on JavaScript today, at least the front end, and using JSON makes it very easy to process your data in JavaScript, right? It naturally parses in JavaScript. You don't have to transform it. You don't have to do anything. It just works, right? Which is why a lot of developers like it. That's why I like it, because I don't have to do any kind of transformations. I just load it up and it's ready to go. So what does it look like? Here we got a picture of my car, and we're going to model it using JSON. So JSON starts with a curly brace, right? JSON objects start with a curly brace. And then we have all these key value properties. So in this case, make is our property, and it has a string value Volkswagen, right? Pretty straightforward. It's separated with a colon in the middle. All of our key value properties are going to be like that. Besides just string values like Volkswagen, we can also have integers. There's not a ton of data validation in JSON. We'll take a look at some of that later as well, but we do have strings, we do have integers, we have a couple other data types that we'll take a look at too. We also have complex objects. So here, right, we got another curly brace. So we're going to see another object as the value of our model. So inside our model property, we have another key value pair. So I have a Volkswagen Golf, and it's the GL trim, which is the baseline model, but I always tell myself it stands for Grand Luxury, because I do love my car, even though it's very old at this point. So we close our object with another curly brace, and commas separate all these properties. If you are from more of a JavaScript background, you could create objects that don't have properties with quotes in the names, but in JSON you always need quotes. around all your property names. That's just the way it works. You can also have arrays. So for the car colors, I've put a few different colors in there, right? Because I got white. That's pretty obvious from the looks of it. But if you zoom in, there's been a few places I've had to get the generic, AutoZone white spray paint to fill in some rough spots. So it's no longer just pure white. And seeing as most of us, all of us are from Northeast Ohio, I'm sure we're familiar with the winter weather. So I've added rust as a color. The broken window is unrelated to the rust. That's just another, downside of Ohio winters and glass breaking. But lots of rust. It's terrible. My car's got 3 colors. Pretty unusual. So besides arrays and integers and strings, we also have dates. And this, funky date format with the T and the Z, if you've never seen it, it's whatever, ISO 8601, I think. It's the standard JSON date format. Don't be too concerned about the letters. We'll take a look at how we can kind of process those later on. And finally, right, a closing curly brace. So when using JSON, this is what we're talking about when we see JSON. It's just a way of modeling your data. I think it's pretty easy to read, and it's easy to use in JavaScript, and it's easy to use in other software as well, including SQL Server now. So, why use it? I was mentioning the JavaScript example just to make it more visual, right? This is why the world has kind of switched over from using it, and instead of using XML, for data transfers and things like that, for using JSON, at least online, because you can literally, right, here's our JavaScript code. You can have your JSON string right there, and just output data. There's nothing special you need to do. It just works, right? Same thing if you need to add properties, you dynamically do that. It gets added to our JSON string. Makes it really easy, and I think that's a big reason why a lot of people have decided to use it. Like I mentioned, it's used everywhere. If you have to work with any vendors, you're getting data from them nowadays. If you're not getting it in a flat file, you're probably getting it through a JSON API, a REST API. Here's an example at Twitter. If you're building any applications using third-party data, you're probably getting it through an API that's outputting JSON data. And so why is everybody, switching to this? Not just the JavaScript benefits, but it's also way smaller, right? So the formal equivalent of JSON was XML. Although it accomplishes the same things in terms of being able to store the same types of data, as you can probably see, right, there's a lot more white space over on the JSON side. There's a lot less characters. So when you're thinking about things like transferring data over the network, you're instantly getting a speed increase just because you're sending a lot less data. Especially if you look at like the colors element in XML, you've got colors, colors, right, versus just one colors property in JSON. You're saving a lot of space, right? And this is only, it's not quite 50% reduction, but this is on a tiny little snippet of code. If you're working on megabytes worth of data, there's big size savings. All right, so let's talk about when is it appropriate to use in JSON? Because when I asked, who thinks it's great to just create all your tables with only JSON in it, as my first slide, I didn't see anyone raise their hands. So obviously there's appropriate times to use JSON, and there's other times where it's not such a great idea. So one of the ways that I use it is to stage my data, right? Let's say I get some data from a vendor, from a third party, and they're sending me stuff. I don't know how many of you have maybe received data from third parties, or if you have to receive it on a monthly basis, but I always have problems with consistency of data not always being formatted the same way. So with JSON, right, if that's the same thing, it's nice to be able to stage that JSON in my database, just dump it into a field, and then do all my validation afterwards, see if there are any errors with it or not. And we'll take a look at an example of that in one of the demos. But once that JSON data is dumped into the database, into some column, we have functions to validate it, make sure what's supposed to be there is there. If there's certain data we're looking for, we can check to make sure it's there and not missing, that the vendor didn't forget to send it to us. And using the new functions, right, it's really easy to transform. And if you have any preconceived notions about these mostly scalar functions being really inefficient. They can be, but there are ways to use them very efficiently, and we'll take a look at that too. Another great example of when I use JSON in a database is for error logging, right? So if I'm building an app and I have some data in memory and my app crashes, which never happens, by the way. No, just kidding, it happens all the time. I want to see what that data looks like at the time it crashed. And usually it's crashing when I'm not around. I get an email later. So if I have a data column like that, that's JSON, I can actually take all my variables that are in memory and store them in a column, right? Sure, there's other ways of doing this. You can create some kind of normalized table with, a column, name and a column value, right, to store all your different parameter values. But then you're going to be pivoting it probably to really look at it, or if you want to do anything with it. Storing it this way makes it a lot easier, right? And on something like this, it's probably not, with error logs, you're not going to be querying that a lot. You're only going to go look at it if there is a problem. So even if you don't have SQL Server 2016, like some of the instances I work on, we're not on 2016 yet, I still store JSON in the database because it makes it really simple to be able to look at that error information. And if I store it, should have mentioned this before, the JSON data in SQL 2016 needs to be stored in an nvarchar column. So even if I'm not on 2016 on some of my servers, I'm already creating my columns as nvarchar so that when we do upgrade, I'll just be able to use these functions without having to go do a bunch of column conversions, or, well, not me, but the DBA, right? So but I want to save him some work too. So, one more appropriate use that I find myself storing JSON in the database for is with non-analytical data, right? So our error logs are kind of like non-analytical data, but if coming from a web background, things like if you're storing web sessions, if you need to store some data in memory that a user's seeing on their screen or whatever, right? Just dump it in the database and then get it back when you need it. It's already in the correct format, ready to go to use in JavaScript or whatever. Things like user preferences, you're probably not going to be analyzing that. If a user has their background color preference saved as blue or red, right? Who cares? I mean, unless maybe you are analyzing it, who knows? But for most occasions, I'm not doing that, so it's a great use case. Also, non-frequently changing variables. So it's like a cardinal sin to hard code anything in your code, right? It's better to variabilize it or get it at runtime. If I have things like administrative email addresses or things like that that I want to store, I'll store it in JSON because instead of just storing an email string, I can store additional information along with it that'll help me process it when I need to. Or things like drop-down menus, if I'm not querying them at runtime and I just want to have some static values, I'll save those in the JSON field as well. Just saves storage, it's easy to use. So those are the appropriate uses. Obviously, there's a lot of bad ways you can use JSON. So obviously, as great as these functions are, I would never advise you to store JSON where you're, on a data warehouse that's accessing that JSON column 1,000,000 times an hour or whatever. There are some ways you can work on performance to do that if you wanted to, but just because you can doesn't mean you shouldn't, right? So, like I said, I'm not preaching a NoSQL environment here. If you have a high transaction kind of database where you're accessing specific data very often, just don't store it in JSON. Convert it to a regular, star schema or some normalized schema when performance really matters. Also, validation and integrity. So even though JSON has some data types like integers and strings, it's missing a lot of the great features, right, that SQL Server has. Foreign keys and different types of numeric data types and not allowing nulls. If your application, obviously you want to validate on the front end as well, but if you need back-end validation, which you basically always do, store it in a regular SQL Server table because there's no way to get that validation without have the developer code everything out and add that validation themselves. So why not use the security that's kind of built in to SQL Server? And let's see, the final inappropriate use that I came up with is just being lazy. That's my cat Charlie being in the way of my keyboard when I was trying to do work. But yeah, it is very tempting sometimes, I will admit, to want to just take all my data that's in memory and shove it into a JSON column. Because, right, I don't have to do any planning, I don't have to create columns, I don't have to think about it, I can just dump it in there. But that's not the right thing to do. Obviously, I wouldn't want to do that outside of development, right? Definitely not in production. So being lazy is not an excuse to use JSON in your database. So with that said, I want to go through 3 demos tonight, kind of real-world examples of how I think people could use JSON in their work environments. Plenty of other scenarios. Like I was thinking about this on my drive over here. Like if you think about it, JSON is really used everywhere. Like everything from, like all the apps on your phones are probably communicating back to some server through JSON. Like that's the biggest thing I could think of. And thinking about Internet of Things and everything else, most of those applications are using JSON as well to transmit data. But I wanted to look at 3 examples more from like either a DBA or a business intelligence developer. How can we use these features in SQL Server? So let me just switch over here to SQL Server. All right, great. So let me just take a sip of water. First example I want to go over is that idea of, hey, we're getting some data from a vendor. We don't really know what the quality of it is. Maybe it's coming to us as JSON, but we want to parse it out and put it into a database. In terms of like SSIS, I'm not on 2016, but I don't think there's like a component or anything built in that allows you to do it. You have to use queries to be able to parse it out. So this is the way to do it, as far as I know. So let's pretend we have this data. This is basically that same data we had before with my Volkswagen. And I'm just going to run this and insert it into our temp data table. Oh, my table exists. Let's try that one more time. All right, there we go. And let's just see what it looks like. Once again, this is an n varchar column. I think I defined it. Yeah, n varchar max. Doesn't need to be max, but if you don't know the size of your data, obviously that's what you'll want it to be. And this is what the data looks like in SQL Server 2016. Now, so for the rest of my examples, I'm just going to open up this tool here. Hopefully it'll work. No, it doesn't, of course. Doesn't seem to work. Demos never do. Let me just get this going here real quick so that we don't lose track of that data. I don't want to have to keep scrolling up on every screen just to be able to reference what we're looking at. Okay, there we go. Cool. So SQL Server 2016, Microsoft. Oh man, I knew this was going to happen. I spent all this time building this presentation. Everyone's interested about this tool. No, it is really cool. It's called it's called OnTop Replica. It is free, and it is pretty cool. You're our hero. Thank you. No, I didn't make it. I have no affiliation with it, but obviously it is super helpful when presenting because usually you are on a projector that has this tiny resolution and nothing ever fits on the screen. So yeah, we'll make this. I want to tell you the wrong thing. It is OnTop Replica. Yes. So it's pretty cool. It's got a bunch of different options. You can play around with it, but I like using it when presenting. All right. It was really funny to see everyone's hand just shoot up. Okay, so with SQL Server 2016, right, there's a bunch of new JSON functions that were introduced to help us manipulate and work with JSON data. Basically, before 2016, if you wanted to do anything with JSON data in SQL Server, you were stuck with one of 2 options. One, write a CLR, which is probably the easier option, honestly. Or two, there's some functions, some UDFs online that would parse, JSON data for you. They were horribly inefficient, but they got the job done. We truly needed it. Which I've had to use those functions. They're not fun. So when these came out, I was super excited. So going back to our example of how do we use these things, right? Let's start with isJSON. Before I run this, anyone have a guess at what this function does, just by the name?
Return a binary.
Yes, exactly. Thank you. What's your name?
Cliff.
Cliff. Thank you, Cliff. That's exactly what it does, right? So our first step of our validation is, let's just run the isJSON function and see if it returns a 1 or 0, is this valid JSON code? And just as an aside, when I was doing the first draft of my presentation, it was an absolute snooze fest because I decided, hey, I'm just going to go through all these MSDN functions and define what they all are. And I swear, if you have like an unruly child who doesn't want to sleep, or if your in-laws are overstaying their Thanksgiving dinner invitation, my first draft of my presentation would have put them to sleep, no doubt. They would have gotten them out of the house. So hopefully these examples will be a little bit more entertaining and interesting than just going through definitions. Yes?
How comprehensive is that? Is it going to go through every row in the garage?
Yeah, it's going to take
JSON in every one of those to make sure it's all cool. So any one of those rows has some mouthful JSON that says that it's 0.
It should, right. It takes the whole string as a whole, done, and just goes through it and sees if the entire string is valid JSON, right? So it's not going to do any kind of validation checks like, is this date time in the right format, right? Because that date time is just a string in JSON. It's not really a date time. Just basic syntax. Does it pass the test?
Does it tell you what the bad one is?
No, it'll just give you a 0. If we just, we could come up here and if I just, get rid of a quote, right? We run this again. My mouse is acting up. We'll just use this, right? If we run this, we go back down. We run isJSON, right? We get a 0 because now there's a syntax error, right? So we don't want to do that. Let me reset my data. Okay, so isJSON, right? It'll just tell you if what you got is valid. So at least, step 1, if your vendor sent you something that doesn't pass this test, just, go right back to them, tell them to fix their data.
Has anyone done any studies on how fast that thing works? Because I can see trying to go against 50 rows of JSON. It might take a while.
It might take a while. I'm not sure. Honestly, I haven't run it on anything very large.
Is there any way to get like a row ID, like what you're saying? Is there like a row ID output or any way to tell you what the broken one was?
I don't think so. From all the testing and playing around with that I've seen, no, it's very basic. But we have some other functions that when we go into parsing the string will kind of help us identify issues if they exist in the data. So let's take a look at those. All right, so I got my data, it's coming in. Let's say I want to parse out. Yeah.
Can you put the JSON string into the isJSON instead of a column reference?
Yeah, so you could just pass in, a string with some quotes around it. Yep. Yeah, or you could pass in, it's either a single value or you could pass in a column for a table and it'll run. It's just a scalar function that's going to run on every single row. So next function we got is JSONValue, right? So let's parse this data out from here. So we're basically passing in either our JSON string or our JSON column, and we then have to pass in this JSON path, similar to XPath. If you've done any XML parsing in SQL Server, it's pretty easy, pretty intuitive to get. But basically we're saying $, that's our root level object, and the outer curly braces, and we're going to select the make property. Right, same thing with, we're going to select the year, model, purchase date, purchase price, right? So that's not in our original data set, but that's okay. So we'll take a look at how you handle data that's missing, right? So in this case it's null, but we have some options there. So out of the gate, The Volkswagen make, 2003 year, they get parsed pretty easily. Our model, which is a complex JSON object, doesn't get parsed at all. That's because it's a complex object, and JSONValue only returns and parses scalars, so single value values. Same thing with colors, right? Colors is really an array of 3 values. It's a complex object. JSONValue isn't going to parse it. Our date time does get parsed, but it only gets parsed because it's a string. It's not really a date time yet. SQL Server is still interpreting that as a string with some letters thrown in there. And of course, purchase price, we don't have in our original data. It's missing, so it just comes back as a null by default. So now that we have some of those fields parsed out, how do we get to the rest of these things? So using the JSON path expression here in the second parameter of JSONValue is one way, right? And so you're kind of just specifying parent.child, right? So model.base, model.trim, and that'll give us the data we need. So if you're getting this data and you know what it's supposed to look like, then great, you can use those functions, right? There's no, as far as I'm aware of, no way of kind of having a schema for JSON, at least no way built in to SQL Server to support a schema so you know what that data looks like. So you have to kind of analyze it and get familiar with it before using that kind of parsing functionality. So JSONValue returns scalars, and it works great for single values. JSON Query is the exact opposite, right? So it's going to bring back any complex objects. It's going to bring them back as a JSON string. So if we run this on our model property, right, which once again is base and trim here, we'll see it returns our JSON string. So maybe sometimes you don't necessarily want to parse those values, but you want to still store them in your database because you don't know if you'll need them at a later date. So maybe you'll parse some of your JSON and you want to save off other parts of your JSON because there's no reason to just do all the work to parse them out now, but you'll save them historically. This is a way you can get a subset of your JSON out of your entire JSON string. You can also use the two in combination with each other, right? So if we just hide this window real quick, so I'll move this over. For some reason the shortcuts to hide it aren't working, but that's okay. So if we have our JSONValue and we pass in that JSON query, right, we can then parse out using our path property here the value from like a child element in a complex object. So definitely there's lots of possibilities for nesting these functions together to get the data you need. Or you could just specify the whole JSON path, right? You don't need to nest the functions. It just depends how your brain works. For arrays, you can parse them using this kind of bracket syntax here, like you can in lots of programming languages. So the numbers inside the brackets represent the index number of the value in the array. So if we want to get the first index, these are zero-based indexes, right? So the first one's white, that's the 0. But that, once again, requires you to know how many values are in your array, which isn't very fun. That means you got to write a loop if you don't know, which loops are really bad, right? We're from a set-based world. Is there something we can do that's more set-based? The answer is yes, for sure. We have OpenJSON, which this one will only work on a string value. So I have a subquery in here, but it's only returning one row of data. If I had more than one row of data, this will not work. So you'd have to do a cross apply or something like that to get this running across many rows. But what OpenJSON will do is return your JSON as a result set, right? So if we pass in that colors array again, we get these nice columns, both with our key. So in this case, since it's an array, it's just going to give us the numeric index of our array value. We have the values, obviously, and then there's this third type column, which is identifying the data type of the data. Once again, the data types in JSON, at least that Microsoft supports here, are not as, I guess, elaborate as what SQL Server offers, but we do have strings, we do have integers, we do have a complex object data type, so we know if it's coming back as a JSON string or not. Dates is probably everyone's favorite topic ever, at least from my experience. I generally don't like working with dates, but it's it's pretty simple to do with JSON and SQL Server. So if we just parse out using JSONValue our date, it comes back as a string. And we've got these T's and Z's in there. So in order to get the full functionality that we want, just move that out of the way real quick, we can use, there's a built-in time format code for the convert function. So if we convert to DateTime 2 using this code 127, it will strip out those T's and Z's for us. So now we're dealing with the SQL DateTime. One thing you may have noticed is we had some zeros added on to our fractional seconds there, right? So it will not know automatically how many fractional second decimal places, right, your value goes to. So in our example, right, somehow I have no idea how I found out the purchase date down to thousandths of a second on my car, but I did, and there's 3 decimal places there. So in order to kind of represent that accurately, instead of getting extra bogus data, we just got to set the precision of date time, right? So that's more of a date time lesson than anything else. And also, so if we look at our original value, the T in the JSON date represents time. So even if this wasn't a date time, if this was just a time stamp that was in there, the JSON, ECMA 5 standard for JSON says all times need to have a T in front of them. Now, what you do is your own business. You can put whatever kind of data you want into there. If you know you're only going to be working with SQL Server, then who cares? Don't bother putting it in there. It just creates more work for you. But that's what that T represents, and that time formatting code 127 in the convert function will get rid of that for you. The Z on the far end represents UTC. So this I actually really like, because there have been plenty of times where I get some date time in a database and I have no idea. Is this UTC? Is this Eastern Standard Time? Was it during daylight savings time? Was it not? Z makes it nice and clear it's UTC. You can also add an optional offset like a plus minus after the Z to indicate hours forwards, backwards. And so using, I think also in 2016, this is new, is at Timezone, you can actually make use of that to format your dates a little nicer. So if you're not familiar with it, it basically will format whatever date you want with the correct time offset attached to that date. So if our date here in our JSON is the date, we're really interested in the time, right, is 3:07 p.m. and we know it's originally in UTC time, we can specify, okay, our date is in UTC, and we're going to save it with our Eastern Standard Time offset. If we run that, right, we'll see no longer is it 3:07 p.m., but we're seeing 11 a.m. with the 4-hour offset. And so these at time zone codes, they're in a DMV sys.time something. Sorry, I don't know off the top of my head. But that's a really cool view that they have there that Microsoft's added, because it'll show you all the different time zones, what their offset is, and are they on daylight savings time or not, right? Which is a huge help if you have to work with dates. So now is the brief SQL 2016 date time demo. But that's how we get our JSON date times formatted into something SQL's more familiar with working with. So do we care if values are missing, right? So in our original query here, I decided to say, hey, let's specify this purchase price property in our jQuery path. Or I keep saying jQuery. Sorry, jQuery is a JavaScript library that I use all the time. But this is a JSON path. And so if I specify purchase price, you'll see it's missing from our JSON data, and by default, it returns null. There's these additional modifiers you can add to your JSON path expression here, lax and strict, right? So lax is the default. That's basically saying if it can't find the data that you're specifying in the path, return a null, right? Don't give me an error message. Don't break my ETL. Just return a null and everything's okay. If, from a validation standpoint, there's some data that we need to have, we absolutely need to have, right? You can add this strict modifier here, and we'll get this nice error message. It'll blow up our job, and we'll know something's missing. So that's a really nice way to kind of validate if there are pieces of data in your JSON that are missing, right, that you would expect. And these modifiers not only work on JSONValue, but they definitely work on JSON Query. I think they work on anything with a JSON path. But test it out for yourselves. All right, so all those functions are nice, but if I had to do this all the time by hand manually, it'd be very tedious. I would not be very happy. Fortunately, there's an OpenJSON function, right? So what this will do is it basically does all that work for us in a single step. Much easier. But it's important to know all those more granular ways of accessing our data, because sometimes that's what we need to do. In OpenJSON, right, the nice thing is no matter if it's like a simple object like a string or an integer or a complex object, it's going to parse it out automatically. We don't need to make that decision. The one other thing to note is OpenJSON will take the with statement here. So we could actually format our data. This is like a nice transformation query where we can use all of the things that we kind of learned in one query here. So if we are expecting a make and it needs to be there, we could say strict. We could bring up child level pieces of data, right? So inside our model, we have our base and trim. We could bring those up to the parent row level by using the path and saying, you know, model.base and model.trim. You know, we could say, for purposes here, right, primary color, I'm just going to choose the first color of my array because that's what I want. And purchase price, even though it's missing, right, we should just see that it returns null. And that's what we get. And the reason now we're seeing one row of data instead of 5 rows of data is because we specified all of these different paths on this side indicating how to bring that data up. It didn't have to deal with the complex objects. It was able to return it all in one row. So if I'm receiving data from a vendor, you know, doing all these validation checks and getting it into a format I'm more used to working with, or into a format that I want to report with, this is a great way to do it. Also, like with SSRS, even in 2016, there's no native JSON functionality, but if you're using these query functions, you can easily report on JSON data. Once again, consider performance. There are good ways and bad ways to do it, but it is possible to do if you're in a pinch. So that's it for that example. Let's take a look at this next one. All right. Time to put this guy away. We're done with him. OnTop Replica. So I'm going to create this table here. It's using basically the same data we're used to. We've got our make, year, base model, trim, colors, purchase date. This is essentially the output of that last query that we saw. And we're going to insert some data. And let's take a look. Right, there we go. So now we've got my Volkswagen on row 1, and we've got my wife's nice new car, single color car, on row 2. Actually, I really like my car. I know it's old. It's got almost 250,000 miles on it. I love working on it. It's saved me tons of money. It's been a great car. I make it the butt of my jokes a lot, but I do really like it. So here's the data, right, that we're working with. And for those of you who are saying, wow, these functions are great, you're working on 1 or 2 rows of data, we'll get to the performance part in a minute, don't worry. Let's just get through the basics. So, you know, let's say we have this data in our database, and now we want to create a new column that basically has that JSON data in it, already structured as JSON. Why would you want to do that? So, as we'll see in the performance demo in a minute, there are very good reasons that developers might now want to format their JSON data up front on the SQL Server before returning that data to their app, right? In the past, that would never make sense. I mean, one couldn't really do it unless you nested 5 million string parsing functions. But there are some performance benefits in certain situations where a developer might want to create their JSON up front and then, you know, just retrieve that with their app. Or, you know, for other reasons, if you're storing that JSON data there, right, maybe then you want to update it with a trigger or something. You know, let's take a look at how we can update and modify existing JSON data. So instead of parsing it, like in the previous example, let's see how we can modify it. So this query we have here, let's just run it first, right? It's using for JSON path. So if you are familiar with for XML path, it's kind of the same idea. It's taking our rows of data, or row of data, here it's both rows of data, and formatting it into a JSON string. Nothing really too different here. The key things to note are any aliases you create, right? Those are your property names. And if you use the dot syntax in the names, it'll actually create these child objects. So model.base, we create a model property, and then there's a complex JSON object here which has two other properties inside of it. So with those dots, you can kind of nest properties together. You'll see here to kind of get my colors array, I'm having to use string split, which is also new in 2016. It's basically the same as any UDF kind of function that you use for splitting a string on some delimiter to get multiple rows of data. We'll take a look at this, because if you look here, right, it's not exactly what our first example showed, right? So instead of having colors and then having 3 scalar values, we actually have 3 complex objects with value properties and then the colors. But we'll get to that in a minute. We do have at our time, our purchase date, right? We specify our at time zone to get the nice Z indicating that our data is originally in UTC format, and we specify the root element or property name. There's also a for JSON path, for JSON auto, which I don't really know what the point of that function is, because it basically does everything this function does, but just it doesn't do as many different things. Like it won't be able to do the dot aliasing and stuff. You have to do join. So I'm not even going to cover that. There are other options out there, but this is the only one that I would realistically use. So yeah, let's get back to this array problem. Can everyone see, by the way, what would happen with that array? I don't know if that's too small or not. Are you guys okay in the back? Yeah? Okay. Yeah, I know, it's pretty bad, right? I mean, it kind of sucks that it's creating all this extra data there, unnecessary data. So I guess this is the official solution to this problem, although I don't think it's a great solution, is Microsoft's written this function here. I think it's from AdventureWorks. I put it here in case you don't have it, you want to grab it. Basically, what it does is this function strips out the property names from a set of objects. So if we add that in, we'll see we can now nicely get our single value or scalar arrays, right, instead of having complex objects. So that tooltip wasn't there. So that is, using that function is kind of the way to go. It's the best way that I know of right now. Hopefully in the future, maybe they'll improve it, who knows. But that's how we get our arrays formatted nicely without having to have properties in front of them. So let's actually add our nvarchar max JSON column to our table here. And let's actually start saving some data, right? So I'm just going to go ahead and basically save that data we were just looking at to our table, right? So now we've got all our data here, and we've got our JSON column with the individual JSON strings for each row already pre-made in case I want to use it in my app. I don't have to process it later on. So, what if the data changes, or what if we just want to modify this JSON data in the database? So let's say, I take my old car and I want to make it a little bit more spiffy. I add some moonroof to it. I just take my angle grinder, add it in, add some other, some new seat covers or something, and basically it is now the GLS model, right, which is the more sporty, higher end model. So I'm just going to call it a GLS so I feel better about the car. So to update it, we use JSON Modify. And this function basically works the same as a replace function, right? You pass in whatever your value you're searching in. You're specifying, okay, what property do I want to update, and then which value am I going to update it with? So it's pretty simple. If we run this, we'll see, right? So take note of our model in here. The trim is GL. After running this, we'll see, and so I'm only doing this now on my first row of data for the rest of these examples, but we should see trim. Now my moonroof car is now a GLS. It has morphed. So JSON Modify, pretty easy, works just like a replace function. At least that's the way I think about it. Right, so now let's say it's time to sell my car, right? So I'm gonna add another column here to our table, and and I want to populate that column, a list date, right? The day I put my car for sale, the day I put one of those for sale signs in my back window, hoping that some teenager will call, because only a teenager would want to buy my car. So, right, we use JSON Modify again to update our column. So what we say, all right, here's our JSON data column. Let's find the list date property, which doesn't exist. So if it doesn't exist, it's just going to add it automatically. And then we want to put in our date. And so here, I kind of, you can see I've got these nested convert functions because this JSON Modify will only accept a string value. It won't accept a date time. So you need to manually do the conversion yourself. But I guess that's what we got to live with, because essentially it is a string, right, that's getting saved to JSON. There is no such thing as a date time in JSON. It's just a string that looks like a date time. So I list it for my date right now, 6:55 p.m. It's for sale. Do I have any takers? Anyone want to purchase it? No. I guess I didn't have list a purchase price yet, but I guess that's negotiable.
Do you have any rims?
Oh, it's got these excellent steel hubs that are very rusty and bent. They might be worth more than the rest of the car, honestly. So, all right. So my car's for sale. It's not doing so hot. No one's, teenagers are getting online and they're seeing the car. They're saying, "Wow, what a great car!" And they go do a Carfax report or something, and the VIN doesn't match, the GLS body type, and so they're a little confused, hesitant. I figured, well, let me remove that GLS trim value because maybe it's a little misleading. Maybe I think it's a GLS, but to the rest of the world, it's not that great. So once again, we use JSON Modify. And so this is really easy, right? We're just going to specify which property we want to delete, and we're just going to set it to null. And as long as it's it's
deleting or updating?
Well, so it's deleting it, right? So if we go look, our model object now here, right? We have our base of Gulf, but there's no more trim property in there. So it is truly deleting it. As long as we are deleting or modifying with the null, but it is truly deleting it from the string, right? As long as it's on a complex object, no problems. On a property on a key value pair, there are no issues. The one thing that drives me a little nuts, and we'll see this here in a second, right? So in addition to getting rid of the GLS misnomer, I want to get rid of the rust. So I do my annual summertime, sand down the back hatch and repaint it. It never stays for more than 6 months, but I'll do it anyway. So I want to remove that rust from the colors. And just to note, right, I could do an update and say, okay, my car is now only white and pearl. This is a contrived example. There are times where you truly do want to delete a value of an array, and you don't want to just update it again, which will be important in a second. But if I want to delete the second, which is really the third value, which is my rust, right, I'm going to try using that same syntax of null. And what happens is very misleading in my opinion. We'll see, to your point, it doesn't actually get deleted. It gets updated with the value of null, which I find extremely irritating because in every other language I've ever worked in, that wouldn't happen. It would actually delete the value and all the keys would shift over. And so I opened up a Microsoft Connect item about this a few months back saying, hey, what's up? And they just said, oh, we set it as a null because we don't want to shift over all the keys, right? If we had deleted white instead, we wouldn't want to shift pearl and rust over. I thought it was a lame response. But that Connect item is still out there. They did offer some advice to add a modifier to the query to actually truly delete values, which I understand. They don't want to break the existing functionality. So if you are interested, if Microsoft Connect things are what you like doing on Friday nights, upvoting them, please go there and upvote it because I would really love to be able to delete easily. Because the way we have to delete is here. Let me reset my data real quick so we get that rust entry back in there instead of null. The only way I have figured out to truly delete items from an array is to use this mess of code. And hey, look, we got 4 XML paths, so we're not just doing JSON tonight, we're doing XML. Everyone's invited. So anyway, I mean, I'm not going to go through this. If you have questions about it afterwards, it's basically we're reconcatenating all our values together. If you truly need to delete something, that's the way to do it. It's a huge pain, but if we run it, we will see that it works. Right, so there we go. There we go. No more rust. Our array is formatted the way it should be. If I have any qualms, all these functions are great, but this one, I guess, misstep really drives me nuts. But there's ways around it, and honestly, I don't do deleting that much. I'm normally just transforming data, right? So if I had to delete, I would probably, unless there was a good performance reason, I'd probably just do it in C# or JavaScript or something like that. All right, so for the grand finale here, how does this stuff actually run performance-wise? So I found this data set on GitHub of basically all years, makes, and models of all cars from 2001 till, I don't know, 2015 or 2016. So if I run this and I create this table, I'm just creating an identity column that's non-clustered with my JSON column called car details. We get almost 20,000 rows of make, model, year JSON data. And so, how does performance run on all this? So if we okay, that's on. Make sure my reminder worked. I didn't forget. Pat on the back there. If we run this query where we want to filter those almost 20,000 rows to only the rows that have Gulf as the model, right? So if we run that, let's see how much of a liar I am because I ran this earlier. Okay, that's not too bad. 149 milliseconds, right? I had 130. I'm recording my screen right now, so I'm sure that software is using some extra resources, but I don't know. I don't think it's terrible, right? I'm happy for disagreement, but it's not the worst thing. What is really cool, though, is we can add indexes to our JSON data. And so unlike the XML data type, which was actually truly a data type and it had its own indexes, and I never really cared for the syntax of them, right? JSON is just stored in regular nvarchar columns, and it just uses regular old indexes. The trick is you need to create a computed column to create those indexes on. So if we just go ahead and add our computed column, right? So I'm computing it right here, and this is non-persisted, right? So for the purposes of performance, these columns don't need to be persisted as long as we index them, because the actual parsed value is going to become part of our index. So the only time that JSON will actually have to be parsed is on that initial insert where it's getting inserted into the index. As long as it doesn't change then, the index is going to keep our parsed value, our table is just going to keep our JSON string, and we'll see how that works. So just as a quick test here, I've got these two queries. I've just added some distincts and into there so our execution plans would, we wouldn't get any parameter sniffing going on. But basically, we got table scans right now. So I've added to our computed column. There's no index yet. It's doing exactly what we would expect it to do. It's having to do a table scan and having to parse out all that JSON. Not that great. However, if we go ahead now and add an index, I'm going to add a clustered index to our computed column. Once again, it's a non-persisted computed column, so it's not taking up extra space there. And we run our same queries here. We should see, execution plan-wise, great. Now we got our index seeks. It is using those parsed values that it's stored in the index to be able to quickly look up which row to return. And so, index seeks, those are like the holy grail, at least part of them, right, for how we want to get our data. So querying JSON data really isn't that bad. If we, spoiler alert, in case you see it, we'll see how accurate it is, right? Okay, 0 milliseconds, 1 millisecond, right? I mean, querying JSON data with predicates works exactly like it does with regular SQL Server data. It's going to be just as fast as you would expect it to be. It's not having to parse every single row, right? There's no row by agonizing row kind of lookups if you're using indexes. And so really having JSON in SQL Server, and if you set it up correctly, it could be really, really efficient. Still, Does it work for every case? No, but it is possible, and it is possible to do well. I wanted to do a little bit more performance testing, and I won't go into it here now. This is more of a kind of a .NET background, but I basically created 7 tests to run, comparing how you parse JSON data and how you serialize, deserialize JSON data in C# using JSON.NET. That's kind of the standard library nowadays for dealing with JSON data. It's the one Microsoft started shipping, I think, with MVC 5 or 6. And it's widely believed to be the fastest JSON parser for most use cases, right? There'll always be edge cases where you can find some other library that does certain things faster, but overall, JSON.NET's the gold standard, and I created these tests comparing SQL servers parsing functions to JSON.NET in C#. And instead of going through all these, I've included these here in case you're curious for yourself to run them, but essentially, we can come back here. Here are results. In SQL Server, right, this didn't really surprise me. The SQL Server JSON functions are slower than just pure JSON.NET. But still, for 20,000 rows of parsing, half a second, I didn't think it was that bad. Definitely, I think it's a case-by-case scenario of when you want to do that or not. If you are parsing, though, I definitely recommend indexes. If you're filtering out a predicate, right, number 2 here, still JSON.NET wins. It's much faster. No surprise there. The big shocker for me was that with indexes, SQL Server just blows JSON.NET out of the water. And that kind of makes sense, right? Because it's kind of pre-parsing it. It's a little bit cheating. But I don't see what's wrong with that. If you know you're going to be querying that data a certain way, you're going to be using certain predicates all the time, certain columns and predicates, why not pre-parse it and save those values in an index if you're going to be constantly using them time and time again? So this is like that scenario where it might be more efficient for developers who are bringing JSON back into their apps. Let's filter our data in SQL Server and then bring it back instead of having to bring everything back and filter it later on. A couple other tests, if you're interested, right? Basically, key things on really small elements. I mean, I couldn't measure any difference. So if you're working with really small JSON strings and objects, I think SQL's pretty fast. I would be happy to use it if I need to do something quick and dirty. I don't see any huge performance impact on that. So, just as a brief recap, right? There's lots of good ways, lots of bad ways of using JSON in SQL Server 2016. I think the functions Microsoft has provided work really well. They're really efficient. I just don't like that one deletion of array values, but hopefully they'll fix that in the future. And if you're indexing your data correctly, it really truly is fast, and it's faster than the C# alternative, right, or equivalent. So before we end, all I ask is, after today, you go look at a table in your database and there's an nvarchar max column in it. You peek in there and there's some JSON data. Don't think it's the end of the world anymore. Think about how you can use these functions to easily and efficiently take a look at that data. So thank you very much. I appreciate everyone's time, and if there's any questions, I'm happy to try to answer them.